Welcome back, guys, to our channel. Today we are going to be teaching you how to find the derivative of a function from first principle. So by definition, the derivative of a function is interpreted geometrically as meaning so if you have the graph of function f of x, and then you draw a tangent line at the point x comma f of x. So at this point, the slope of the tangent line, the slope of this tangent line at this point is the derivative of x. So it's defined as f prime of x. That is the definition of the derivative. But today we'll be teaching you how to find the derivative of a function. So using the first principle, there are a lot of rules, but we'll get there in subsequent videos. So today we are going to begin with what we call the difference quotient formula that you were taught in pre-calculus. Now, this is the formula for the derivative of a function. So definition of the derivative of a function. That's f prime of x. This f prime of x stands for derivative. The prime notation, f prime of x is equals to the limit of f of x plus h minus f of x all divided by h, and as h approaches 0. This is the definition of the derivative of a function. And using this expression, we can find the derivative of any function using this particular expression, whether trigonometric, whether exponential, polynomials, and so on. So let's begin by finding the derivative of this function for the first question we're given. So once you want to find the derivative, there is one thing you need to know. You already have the function f of x. You need to know what will be f of x plus h. So let's find out. We know that f of x is x squared plus 1. So what will be f of x plus h? So if we're finding f of x plus h, simply put, we are going to replace. So what you observe here is that x is replaced with x plus h here. So on the right hand side of the equation, we are going to replace x with x plus h. So this is going to give us x plus h all square plus 1, because it is x squared, and x has been replaced with x plus h. So f of x plus h is x plus h all square plus 1. And we're just going to plug this into the formula for the definition of the derivative, and we simplify the result. So f prime of x is equals to the limit. What is f of x plus h? Is the value. So that's x plus h all square plus 1 minus, what is f of x? F of x is x squared plus 1 all divided by h, and as h approaches 0. So you replace the value of x plus h, and then you replace the value of f of x, and you simplify the result. So f prime of x will still be equals to the limit. Now x plus h all square plus 1, let's simplify. If we simplify x plus h all square, we are going to have x plus h times x plus h. And using the FOR method, we have x squared plus 2xh plus h squared. So the FOR is FORL. The first term, x times x, gives us x squared. The outer term, x times h is xh, h times x is xh. We add xh plus xh, we have 2xh, and then the L stands for last. So h times h gives us h squared. We have plus 1 minus, so this negative is going to affect everything here, minus x squared minus 1 all divided by h, and as h approaches 0. So once we do that, we can simplify. So it's very important to know that at this point, all of the terms without h are going to cancel out. All of the terms without h are going to cancel out. So we have x squared and x squared will cancel out. So this and this will cancel out. And then you have 1 and negative 1 going out. So you'll be left with the limit of 2xh plus h squared all divided by h, and as h approaches 0. So to simplify this, we can factor out an h from the numerator, or we divide each term by h. We have the very same thing. So f prime of x is equals to, so we have the limit as h approaches 0, h parenthesis open. If we factor out an h from here, we have 2x. That's 2x plus. If we factor out an h from here, we have h, all divided by h. So h and h are going to cancel out. So we have f prime of x to be equals to the limit of 2x plus h as h approaches 0. So this is just the limit of a polynomial function. And to evaluate this, we use direct substitution according to what we learned in calculus 1 from the beginning. So we have f prime of x, which is the derivative of f of x, is equals to 2x plus 0. We replace h with 0. Finally, f prime of x is equal to 2x. Therefore, from the first principle, differentiating from first principle, if f of x is s squared plus 1, then f prime of x, which is a derivative, is 2x. So you are going to try this problem and post the solution in the description box. Follow the very same method, and you are going to get the answer. So the answer to this, if you find f prime of x, you should have f prime of x is equal to 6x. This should be the result. Thank you very much, and we hope to see you in future installment of our videos.